Good morning, good afternoon, good evening, depending on what time it is when you're watching this. Welcome to 10 Entity Framework Features Every Developer Should Know. My name is Phil Jupixi, and just a little bit about me. I'm a .NET Enterprise consultant. I do a lot of Agile coaching. I'm a trainer for LinkedIn Learning, formerly Lynda. I write books for Apress, and there's my contact information. Skimatic@outlook.com is the easiest way to get a hold of me. Also on Twitter, Skimatic. And that name came about because I'm a retired firefighter paramedic and have spent the past 30 years on the National Ski Patrol. All the samples that you see in this presentation are available on GitHub, and that link is at the bottom of your screen, github.com/schematic/efcore-top10. The agenda today is very, very simple. We're going to talk about Entity Framework and the project status. We're going to do a little discussion about which Entity Framework is right for you. And then we're just going to dive right into code. I've got 10 demos that we're going to show some awesome features within Entity Framework. So let's talk about the Entity Framework project status. And it really should be projects status because there are two live Entity Frameworks. Entity Framework 6.1, full featured, been in production for a long time, lots of people using it very successfully. Then there's Entity Framework Core, which currently is in 1.1 version, and that coincides along with ASP.NET Core and .NET Core. Now, the important thing I want to point out is that Entity Framework 6 is not dead. It is still being developed. They are working on Entity Framework 6.2 as I teach this course, with Beta 1 followed by lots of bug fixes and Visual Studio 2017 support. At the same time, Entity Framework Core 2.0 is being worked on with lots of additional features, some that were in 6.1 and didn't make it into Entity Framework Core, and others that are brand new to Entity Framework. No talk would be complete without the birthday cake architecture diagram. So we have one here. You've probably seen this a million times. You'll see it again. We've got the infrastructure libraries across the bottom, the .NET standard library in the middle, and then the different frameworks across the top and the tooling on the right. So where does Entity Framework fit in? Well, again, we have two frameworks to talk about. So let's talk about Entity Framework 6. It is Windows only runs on the .NET framework. Then we bring in Entity Framework Core, and it runs everywhere. You can run it on Windows, you can run it on .NET Core, you can run it on Xamarin. So you really do have two choices, and we're going to discuss those choices now. So, which one should you use, Entity Framework 6 or EF Core? Well, largely it depends on what you're doing and trying to accomplish. If you're already heavily invested in Entity Framework 6, there's no reason to throw it all out and start over. Entity Framework 6 is Windows only, so if you are not thinking about going cross-platform, it is a perfectly viable option. It's full-featured. It's been under development for 8 years. As I mentioned earlier, they are still doing patches, minor releases, lots of good stuff coming. And it's widely used. Chances are, if you run into a problem with Entity Framework 6, you can quickly find an answer on Stack Overflow or in the documentation. Lots of articles, books, examples out there for you to use. Well, that being said, why should you look at EF Core? Well, EF Core is the cross-platform alternative. If you are looking to do a cross-platform ASP.NET Core solution, EF Core is the ORM of choice. But it also works on Windows, and we'll talk about that more shortly. It is brand new. It's missing not a lot of features anymore, but missing some features from EF6. And if it's missing one of those features that's an absolute deal breaker for you, then you're going to have to stick with EF6 on Windows. Now, EF Core 1.1 significantly closed the gap between EF6 and EF Core, and a lot of those features are what I want to talk about today in this class. And the documentation is catching up. Some of it's a little rough around the edges, not a lot of examples out there, but there's enough that you can keep moving forward. But there are many improvements over EF6. It is brand new, written from the ground up. That means a lot of that technical debt that was carried forward over those 8 years of developing EF6, Microsoft didn't have to deal with. Start over, better development techniques, better practices. We always learn from what we write, and we write it better the second time around, and that is absolutely true with EF Core. It is significantly faster than EF6. There are features that they're bringing into EF Core that they could not bring into EF6 because of technical debt. And it works with EF6. I have a customer right now that I'm working with. They've got a very large MVC5 application using EF6. They're having performance issues with data access. We are working with them to bring EF Core side by side with EF6, and we're seeing significant performance improvements. Now, there is an asterisk there because it's not simply plug and play. There's a little bit of work you can do, or that you need to do, but it does work very well side by side. All right, so enough of the slides. We're about to jump out into these 10 features that I think, again, this is my personal opinion, but these are the 10 things that you really need to know about Entity Framework. First and foremost, the improved performance. Got a great demo from Rowan that shows how much faster EF Core is than EF6 going against AdventureWorks. Batching of calls, that helps with performance, but it's also customizable. Field mapping, brand new in EF Core. Connection resiliency, brought back into EF Core with 1.1. Concurrency, mixed mode evaluation. The from SQL, that is using raw SQL to populate your models. Improved migrations. Now, I say migrations, there's probably several of you out there that just groaned having been burned by migrations in the past. Much, much better in EF Core. Computed column support, and then find, which was brought back. And that is the last slide. We're going to dive right into code. All right, so the first project we're going to look at is just a little performance test, and it goes against the AdventureWorks database. And if we look at the code, it's very, very simple. The first test, it's going to pull back 19,000 records. Does it with EF6 and EF Core, then it does a more complex query. And then it adds 1,000 records and save those changes. Now, there were some tweaks you could do in EF6 to get a little better performance, and that is with auto-detecting of changes, turning that off. So just to show still the improvement of EF Core, we run that last test again using the EF6 optimized. Now, I can talk about it for a while. Let's just show the numbers. So here we go, the first iteration. We're pulling back 19,000 records. I am running on a Surface Book. This is an i7. It's the 500 gig hard drive. So it's certainly not what I would consider a server machine. But when you look at the exact same execution pattern for EF6 versus EF Core, anywhere from 70% to 99% improvement in performance. Same models, little different context, but exact same code. And this is because of the optimization that the EF team has been able to do by starting from scratch. Now, this is demo code, so you're probably thinking, how much faster is it in real life? I don't have numbers to show, but I can tell you that the performance that we're getting with my customers where we're switching out EF Core in place of EF6, we're getting significant improvement, like noticeable improvement from the users. All right, let's talk about batching. One of the reasons that the performance is so much better in EF Core is that the statements are batched. And what I mean by that, in EF6, if I have 3 updates and I call save changes on the context, It does go as one transaction, but there's 3 individual calls that are sent over to the database. EF Core changed that into one call using temp tables and some other SQL magic. It's not really SQL magic. We've been doing it in the SQL Server side forever, but it becomes one network call. And the best way to demonstrate that is to actually show it. So I have Performance Profiler here. We'll go ahead and start it up. And we're going to run. We're actually going to set the project to the right project. And the first run goes with default batching. In other words, that's the EF Core default way of sending data over. To make this easier to read, got a breakpoint, clear out what's in there, go back into Visual Studio, step over the line, and we'll look at the results. So here we have a batch. And we declare a table. Well, not we don't. Entity Framework's doing this for us. It declares a table with all the fields, inserts the values, runs the operation. Now, why does this matter? Well, this matters greatly if you're in the cloud. So if you are sending 4 or 5 network calls up to the cloud, that's going to cost you more than one bigger statement. So the batching is very, very good for performance, very good for cost reduction in the cloud, but it's not always perfect for everybody. So it can be adjusted. We go back into the code and we're going to set up the database without using the default batching. And we do that very simply by setting the max batch size, easy for me to say 3 times, to whatever number you want. Now I set it to 1 so that it will mirror what EF6 does. Go back into Profiler, clear out what's there. Let's run this next line. It's the exact same statement, but what we're going to see is we're going to see multiple calls going across the wire. Is batching always going to be faster? I don't know. Nobody knows. But what EF Core does is gives you the ability to set it up so it's optimal in your particular environment. All right, I'm going to pause the trace, go back into the code, and let's look at our next demo. So we've covered the performance improvements. Batching is a big part of that. The next thing I want to talk to you about is field mapping. Now, one of the big complaints I do a lot of WPF development, and I use notify property changed everywhere. With EF6, we had access to the interceptors. So we could do things like on the object materialized event, set the isDirty flag to false. Well, those aren't yet supported in EF, but field mapping allows us to get around that. And field mapping means that I have an entity, let's say here, again, a blog, right? We try and keep the examples very, very simple so that we can talk about the tech and not get lost in domains. And I have this name property, and it's got a backing property underscore name. If Entity Framework Core sees a backing property following that naming paradigm, underscore name or M underscore name, it will presume that that's a backing property and it will use that property or that field to materialize the object. So in this case, I'm faking out the unnotified property changed. If I call this through regular .NET code, I'm setting properties through my application, the property changed method gets called. When EF calls into my blog object to create a new blog object from the database, it will use the property instead of the setter, therefore avoiding the property change event, which is what we really want. So to show this demo, it's also very, very simple. We're going to set custom properties through C#, and we should see the event fire, or the fake event, I should say. My apologies, we're back in batching. Got way too many projects in here than I normally use, but I wanted to keep it clean so that you could have each individual project as a demo to play with on your own. So now we really are field mapping as the starting project. That's what we get for live TV. Sometimes we get errors in there, but we'll just keep plugging forward. So each of these creates a database from scratch, so that takes a little bit of delay. All right, so now I'm going to set the property through C#. So I create a new blog object, set the name to .NET Musings, set the URL, add the blog, and save the changes. If we look at the console window, we see that the property changed was called. So now we're going to set properties through the Entity Framework materialization. So we just do a very simple query, blogs order by. We're going to talk about this query in just a second. I want to talk about the materialization skipping the setter. And then we go through each of the blogs. We'll just run it to the end, and you'll see that it does not hit the property. So while we don't have access to the interceptors, and I know that's still very important for many people out there, from a WPF scenario and utilizing property changed, you now have in EF Core what you need to keep moving forward. All right, let's talk about some other things that we can do with this field mapping. I've declared a property called URL that's a string, but it doesn't really exist on the object. What I have on my blog object is a setter and a getter for those. Now this is different than a shadow property, because shadow properties are tracked by the DB change tracker. This is really just a virtual fake made up property, if you will, that is only accessible through code and through EF. So lots of power in the field mapping. From my perspective, this is awesome because, again, I do a lot of WPF. Your mileage might vary on each of these, but let's move on to the next demo because I am limited by time. And we're going to remember to set the new startup project this time. All right, connection resiliency. This was another thing that was missing in EF Core 1.0. And had a lot of people kind of got their hackles up. What connection resiliency is the ability to automatically retry when certain transient errors occur. So if you're working with a cloud-based database such as SQL Azure, you don't want to have your application choke and die every time there's a little glitch in the matrix. What you'd like to do is, if these certain things happen and you know for a fact that they're transient errors, you want it to be able to retry a certain number of times. EF Core 1.1 brings this back. It was always in EF6. And there's a couple ways that you can handle connection resiliency. So let's look at the on configuring. And the simplest way, if you're using SQL Server, which all my demos are, is to enable retry on failure in your options. What this does is this brings in a new SQL Server retrying execution strategy, and it was created by the brilliant engineers at Microsoft to say, hey, if you're using SQL Server or SQL Azure, these are all the things that might happen that are just glitches where you should retry. And it sets a default retry and the max delay. So what happens is your application, you call save changes, or you're doing a query, it gets this error, it delays, tries again. When it hits the max number of errors, it does finally say, yep, you know what, I'm done, I give up. I'm going to raise an error, and that error that it raises, right here, the retry limit exceeded exception. So this tells you that there were transient errors, but they were so repeated that Entity Framework just had to give up. Returns you back this error. The inner exception is the actual exception that caused the problem. So what if you don't like the SQL Server retry strategy? You can make your own. And it literally is this simple. I create a new class. I derive from execution strategy. I want to set a couple constructors because this is how we have to configure it in the DB context options. And it takes in an execution strategy context. Takes a max retry count and a default max delay. One method that you care about is you should retry on. If you return true out of this override, it will retry up until it hits that max retry count, delaying the retry delay. To plug that into your particular context, all you need to do for the options, I guess I should have spelled these out better. Do a little live typing. I try and avoid that because you don't want to see me type. You want to learn the content. So here are the options. Set the execution strategy to a new custom execution strategy with the max retry delay or max retry count and max retry times. Now I apologize for the name. Custom execution strategy is a pretty weak name, but you know what? The three hardest things in software development: naming conventions and off by one errors. All right, so that's connection resiliency. The next topic I want to move on to is concurrency. Let me make sure I set this to be the new startup project. We'll close all documents, save those changes. Now this has been around for a while, but what's new in EF Core 1.1 is some of those familiar APIs that we leveraged very heavily in EF6 to handle concurrency issues. So what is database concurrency? Well, I get something out of the database. Walt gets something out of the database. I save my changes. Walt then goes to save his changes. We have a concurrency issue because his changes are now going to overwrite mine. The way Entity Framework handles concurrency with SQL Server is actually very elegant. We have a timestamp data annotation, and we can also set this through the Fluent API. And this tells Entity Framework that the column named timestamp, and I just happen to name it timestamp here, is actually a row version column in SQL Server. And a row version translates into C# into a byte array. Row version is very specific to SQL Server, and it's kind of a magic column. Every time that a database row gets changed in any way, shape, or form, it's added or updated, the row version gets updated as well. By declaring this a timestamp right here, what happens is Entity Framework changes the query it runs just a little bit when it's running update or delete statements. Instead of just saying update blog where blog ID equals 5, for example, it'll send into the database update blog where blog ID equals 5 and timestamp equals this byte array. And if it doesn't match, then it knows that something has changed. So let's run this and see the query that gets generated. Again, it's creating the database each time, so we have a fresh start every time. All right, we're going to back up to again, live TV, my apologies. Breakpoint in the wrong line. Let's run this again. All right, so we're going to create the database. You don't need to see that code. That just calls ensure created. We'll talk more about that in migrations. What I really want to get to is the where clause when we call the update. All right, so I create the blogging context. I'm going to add a blog, call save changes. Now what I do is I just running a straight SQL command here that changes the database out from under me. So I have this blog object in the DB change tracker. It's got values, it's got a timestamp, and I change the name and then I call save changes. So we'll start the trace again. We'll call save changes. We got an exception, but let's look. So right here, you can see that it's saying update where primary key equals 1 and I don't know how to read a row version, but we're just going to call that 7D1 because that's the letters that show up. So it's checking for both of those to make sure that the value that is in the database matches what I am trying to pass in. Now, it doesn't match, it fails, so we get an exception. Now the exception's a little misleading, I think it is anyway. It's called a DB update concurrency exception. The name matches, but it doesn't mean that you necessarily had a concurrency error. What it means is that the number of changes that successfully made it into the database is different than the number of changes that the DB change tracker expected to have happened in the database. More often than not, that's a concurrency issue. But I just want to be very clear that it's just telling you that those numbers don't match. Now the DB update concurrency exception gives us a ton of information that is very, very good for us as developers when we try and sort through what could have happened to the user. There is an entries property, and this is all of the entries that the change tracker expected something to happen, but nothing happened. In this case, we only have one entry because we're only trying to update one thing. We get two sets of property values exposed by this entry entity object, and that's the original values. In other words, the values that were loaded when we first pulled this object from the database. The current values, these are the values that obviously are currently in this object, what the user changed them to. We also have access to the modified properties, and it's not a very simple property, but it is a very simple link statement where we say we take all of the properties where they are modified, and that gives us all the modified, and that gives us normally a significant portion of what we need to build a UI to help the user rectify the situation. Two methods that came back in 1.1, largely because of the community asking for them: get database values and reload. So these were not in 1.0. Get database values makes another call to the database. And actually, you gotta keep this in mind, it is making another round trip out to the database, but then it brings back a property values object showing all of the values that are currently in the database. So now you can build a very robust screen that says to the user, here's the original values, here are the values that you changed them to, and oh, by the way, here's what's in the database. And you could have them pick and choose which ones they want to keep and then save again. Or you can go the easy way and punt and call reload, another API method brought back in EF Core 1.1, and that just reloads the object from the database. So the concurrency capabilities within Entity Framework don't solve anything, don't solve any of the concurrency problems for you, but they give you all of the tools necessary to make sure that you can solve them yourself. Very, very powerful stuff. Matter of fact, so powerful that I keep all of my entities. I have a base entity class that I use in all my projects, and you'll see this in my Lynda courses as well as my books, that has two properties, the primary key and the timestamp, and everything derives from that. Now, if your application doesn't care about concurrency, you can just ignore it. All right, mixed evaluation. This is brand new in Entity Framework. And what mixed evaluation is, it's client-server evaluation. So you've got some method that you want to execute, a C# method, that you want to combine with your link statement. So we have right here just a where clause where we're using a C# method. Now this is very, very trivial, but again, don't want to get too lost in the domain of an example, but show the tech behind the example. So if the name has the word blog in it, and this is a C# method, then pull it back. Now EF6 would have a hard time with this because it's mixed mode. Entity Framework doesn't know how to change this C# method into a link statement. Now if you're new to Entity Framework, then I need to fill you in. The way link works is prior to mixed mode evaluation, it runs on the server. And it runs when that list is enumerated over, or if you call toList. So I can keep building up this link statement, adding where clauses and order bys, and those, however I need to build it up. Once I call toList, executes on the server very, very fast. Well, there was a need to tie C# or client-side functionality into that. So that's what mixed mode evaluation does for us. I can have a link statement with a C# method and then another link statement. Now, I have to warn you that this can turn around and bite you really, really hard in the foot. If I do a get all, and then I say where it has this word in it, and then start doing more link, guess what I have just done? I have done a get all to the client. So you have to be really careful about where you put your client evaluation or your client function. This is probably not a very good example because it's going to bring back all of the blogs, then process through the function, and then create the list. So if you're worried about performance, and I just had this happen, I mentioned that I was converting Entity Framework 6 calls to EF Core for a customer of mine, and I was doing a search for a GUID, database property or GUID, and the method, the C# method, was getting passed in a string. So I said, very simply, where x lambda, x dot, I don't remember what the field name was, it doesn't matter, GUID field name equals GUID. Well, that ended up being a client-side evaluation. It pulled back every single customer in every single customer record in their database, and then client-side converted to a string and parsed it out. So I recommend that you turn off mixed mode evaluation to begin with, and then if you need it, turn it back on. Unfortunately, at this point in time, you can't turn it on and off based on an individual query. It's at the context level. And the way you turn it on and off, it's actually not even turning it on and off. That's kind of a misnomer as well. We'll get back into the code here. Is we basically we have a warning turn into an exception. So we configure the warnings and we say, hey, if we get the query client evaluation warning, change it into an exception, and then it'll become a runtime exception. So hopefully in EF Core 1.2 or 2.0, so in other words, some version soon, we can turn it on and off by query. Right now, it's only at the context level. All right, the next topic I want to cover is bringing back objects from raw SQL. Now, this is a little misleading, is too strong of a word. Entity Framework 6 had an incredible amount of power dealing with raw SQL and the things you could do. Matter of fact, even in the model creating, you can set up an entire entity to be based on stored procedures. EF Core is not that advanced, but what it has is very, very nice. What you can do is you can populate any DB set in your context from a raw SQL query, such as a user-defined function, or, it's kind of taboo, you shouldn't do it, but a raw SQL string right in your code. And you can combine those with link statements to make a more narrow view. So for example here, I've got the blogs that we've dealt with the entire time, and I have a user-defined function, search blogs, takes in a parameter. So I can say db.blogs from SQL, pass into SQL, and then I can continue with additional link. So the user-defined function will fire, returns a list of blogs, does an order by, and does it all server-side. And just to prove that's true, let's go back into Profiler. Takes a minute to build a database. Make sure I've got the profile cleared out. I do. All right, now we're going to get the data from the function. So let me turn the profiler back on. I just want to try and eliminate all of the noise that comes to the profiler. And we're going to call this right now. Now, it won't show up yet until we actually iterate through it. New feature in 2017, run to cursor. I love that. All right, and we go in here, and you can see, select those fields from that function, order by. So that's all happening server side. And again, from a performance standpoint, the more you can have done server side and reduce that result set before it comes back client side, the better performance you're going to experience. Now, another thing you can do with this, and I just learned this recently, and this is, I think, really awesome, is it doesn't even have to be a table in the database. So I have this short blog class, silly name, I know, and it just doesn't have a name, blog ID and URL. So it's a subset of the blog. And there's a couple ways in real life that we can populate this, right? We can certainly get blogs back, do a projection with link to populate the short blog. But what if I want to do it straight from SQL? I just say select star from blogs, and it'll populate. And you go, whoa, hold the farm, that can't be true. There are some rules. First and foremost, every field that is in your class that you're populating has to be represented in the query. Select star is not a good way to do it. I should have named the field individually. The short blog, my particular example here, also has to be a DB set on your context. So here I have short blogs to DB set on the context. I've added not mapped in case you're using migrations. That way I won't try and create this table. And you have to define a primary key. And I can do that very simply in the on model creating. Just say short blog has key blog ID. And I'm off to the races. We're using this in production in place of pulling back the full model or several models and then doing AutoMapper or those types of projections. We're actually doing this with EF Core to pull the data straight into our view models, and we're finding very nice success with this. All right, I'm going to talk about migrations next. So go ahead, Grown. I know we've all been burnt in the past by migrations. They seem to have been a necessary evil for a long time. And I want to tell you that the Entity Framework team did an awesome job of listening to the community, hearing what the pain points were with migrations, and saying, we got to fix this. So if you're not familiar with migrations, it is a way to either create the database from your code or create the code from the database. So you can scaffold your context and your classes from an existing database, as well as you can create a database from code. And this worked actually pretty well until it didn't. And it was one of those things that I've run into in the past where everything is running swimmingly, and then all of a sudden it stopped working, and you pretty much have to just nuke it from orbit and start over. One of the problems with EF6 is how it kept track of the changes. So there's a migration history table that you might have noticed. And in EF6, what gets stored in there is the name of your migration, version, but also a hash of the database. Well, hashes are inherently one way. So if I'm working in a team environment and I make a change to the database and you make a change to the database, now we have two hashes. We can't really see what the changes were. So the Entity Framework team addressed that on a couple different fronts. First and foremost, if we look at the migration history table now and what is contained, and that's a really small font, I apologize, the one thing I forgot to change. But just suffice it to say, there's only two fields: the name of the migration and the product version. The hash is gone. It's no longer stored in the database. So you wait, hold your horses. Where did that go? Well, it is now a C# class. So if I look into the migration sample and I look at this blogging context model snapshot. Now the model snapshot name is added on. The blogging context is the name of your context. This is a C# code that represents your model as it exists based on your entity classes and your DB context derived class. If we're in a team environment, I can now use any merge tool to look at the differences between what I've done and what Walt has done to the database, and we can very quickly figure it out. So no longer do you have to have one person in charge of migrations and nobody else allowed to touch them, right? It really works as a team environment. There are a couple other differences I do want to call out. In EF6, we could remove a migration just by saying its name. We could say .NET EF migrations remove, and the name of the migration doesn't exist anymore. Makes total sense. You don't want to pick one migration out of the middle of a whole stream of migrations and take it off the board. .NET EF migrations, or remove migrations if you're using Package Manager Console and not the .NET EF, only removes the last migration. You can script just like you can in prior, and this is actually what we do in production, is we will say .NET EF migration script, beginning migration, end migration, or if you leave it blank, it goes from the beginning of time to the end of time, what file you want it in, and if you want it to be idempotent, in other words, if it's not dependent on any other migrations. So this is great if you're in an environment where DBAs have to approve all changes. Absolutely. I totally support that. The more eyes looking at something before we put it into production, the better. Create the script, hand it off to them, let them go to town. Now, one thing about migrations, and this isn't new, but just to keep in mind, if you want to run custom SQL, all you have to do is create an empty migration, and you can call migrationbuilder.sql. For example, here I am building a user-defined function. You also want to remember in your down method of that migration to drop the function. A couple things that you don't see in EF core migrations that you might have used in prior versions. If we go back into the model snapshot, which used to be called the configuration class, there is no seed method here. So there's no way to automatically initially seed a database using migrations. And honestly, I think that's kind of a good thing, because if you forgot that was in there, seeding is great and you can write your own in EF core. But if you forget that it's automatically seeding database in your older production, then you can have some significant problems. So To sum up the changes with migrations, the good no longer uses a hash to check the database state. Model snapshots now a C# file that contains all of the DDL. And the database migrate command, oh, we didn't touch that. It's a good thing that I'm looking at my notes. I want to talk about ensure deleted, ensure created, and migrate. So ensure deleted and ensure created combined is similar to drop and create database always, which existed in EF6. Ensure deleted says, hey, if this database exists based on a connection string within the blogging context or those context options, then delete it. If it's already deleted, we're happy, move on. Ensure created will then create the database based on the model. Now this is important. It's going to use that model snapshot class that we looked at right here, and it's going to build up your model. So it'll match all of your code. But if you have migrations in there to create things like stored procedures, to create user-defined functions, or to do anything else, they will not get executed. So I've gone away from using ensure created, and I stick with migrate. So the context.database migrate is a combination of ensure created and run all migrations. So just something to keep in mind if you're doing this on your own. All right, 2 more topics. Looks like we're pretty much on time schedule-wise. The next one is very near and dear to my heart because it did not work in EF Core 1.0. I was the one who logged the bug and the samples. Well, actually, several people logged the bug, but I ponytailed on that, and we got it resolved. Computed columns. So I am not just a C# developer. I do a lot of database admin type work too, although not as much as I used to. So I'm not a type of developer who wants to have everything in the database or everything in code. I like putting things in the right place. So if I have a situation where I'm doing set theory to provide values to another table, I absolutely will want to have a user-defined function for a computed column to get that value. For example, if I have a very simple e-commerce site and I have an orders table and an order details table, I would like in the orders table the total of all of the order details without having to run a query each time I get the data to populate the order details. Very simple to do on the database side with a user-defined function that the order total column in the order table is defined as a user-defined function that then calls into the order details, sums it up, and shows the value. Right? It is set theory 101. And if we look at the SQL for that table, and this font might be too small. I know how we can do it. Let's do this. Script table as creates to new query window. There we go. That's bigger than it would have been. So here we very simply have the order total as this function takes in a parameter. Super easy to do on the database side. Unfortunately, in EF Core 1.0, this caused all kinds of problems. I will tell you, once I was able to get a test that showed it definitively, the EF team was all over it, had it working pretty quick, and now it works very, very slick. But there's some things I want to point out to you as to how to configure this from an EF standpoint. So whereas I believe that you should intermix database code and C# code where it makes the most sense for your application, you also have to keep in mind supportability for other developers. So if I've got a new developer starting on this project, I don't want them to have to run the migrations, run a bunch of SQL scripts, right? Do a whole bunch of friction causing cruft to get their system up and running. I want them to be able to hit F5 and be off to the races. So that brings us back into migrations. So I've created the first migration, right? Just normal. I've got a migration based on my columns, 2 tables, orders, order details, creates the columns, no computed values whatsoever. I then create a manual migration that creates the function. Once I have the function created, I can then add in the computed column. This is where you have to know your database provider. SQL Server will not allow you to change an existing column into a computed column. So you have to add the column after the function exists. So that's how the migrations read. A lot of code there, not expecting you to type any of that. All you need to know is this, and it's actually very, very simple. I go into my context, I go into my model building, and I say, my order table has a property called order total, money type of, or column type of money, and has computed column SQL. This is a method on the model builder, and you just pass in the SQL. This will automatically create that computed column on the table for you. Now, one thing that did work in 1.0 and still works in 1.1, thankfully, is you could always do a very simple computed column that was based on the same table. So my order detail table has a quantity and a unit cost. I want to have a line item total. I just put quantity times unit cost. Works great in EF6, worked in EF Core 1.0, and works in EF Core 1.1. So here's my computed column, and that literally is how simple it is. Now, when you look at the code, sometimes I get a little defensive in my programming. So we look at the order total. One thing I could have added in here is called it a computed column with the data annotations, but it's not necessary since I did that through the API. Now, I will tell you that the Fluent API is the only way to set a computed column to a function or even a computed column to 2 fields on the same table. All right, so that's computed columns. I could run the code and it'll profile and it'll give the sum, but there's nothing too exciting there. I only have one more thing that I want to talk about, and I think this is also very important. And this also shows how important the community is to the Entity Framework team. So find was a method that was in the older version. Well, it's still a current version, but in EF6. And the way find works is a little different than just calling a get. So let's show the code. I can call first. I can put a where clause in there. Either way, I'm getting one blog back from the blogs table. This goes out, makes a database call. By now, you should know exactly how this works. Find works a little differently, and I can call it on the DB set itself, db.blogs.find, right? So I could do this. Now let's be creative with our names and call it 2a equals db.blogs.find and pass in the primary key. Now this only works for primary keys, but I can also do it directly on the DB context. So all the methods, I'm sneaking in an 11th feature here. All the contexts you can do add, update to all the CRUD operations directly off the context. You just have to tell it what DB set it is. But both of these do the same thing. By primary key, it looks in the DB change tracker first to see if you've already pulled back that object. If it has, it hands it back to you. If it hasn't pulled back that object into your instance of the DB change tracker, it will then make a database call. So this I do want to trace into. We're going to comment that out. So create a new database, create a new blogging context, We're going to make a database call to get the first object. Creating a database takes a few minutes. Well, it actually takes a few seconds. Here on camera, feels like a few minutes. All right, let's clear out the trace. It is running. Go back into our code here, and we step in. All right, and what did it do? Okay, select top one from blog. Let's clear it. Now let's call find. And we're back here, no database call. And we go back here, and now we're going to call first again, passing in a where clause. And once again, we get a database call. Now, how much of an impact this has on your code? You know, there were some people in the community that said we don't need find. There are other people who argued very eloquently how important find was to their particular code. The important thing is the Entity Framework team listened, they responded, and they returned a feature that many, many people had a very important need for. And with that, I am just about out of time. I'm going to once again put my contact information up. Probably the easiest way to get a hold of me is Skimedic on Twitter. That's as in snow ski paramedic, not like a database schematic. And all of these examples are available on github.com at skimedic/EFCore top 10. Thank you very much. Have a great rest of your day, evening, or weekend, depending on, again, on what time it is when you're watching this course. My name is Phil Gepixie. I've enjoyed being here.